Hi students, how are you? I think it's fine. Myself, Tanmoy Dotto, Assistant Professor, Department of Chemistry, JS College of Engineering, Kollani, welcome you all in the class of Oxidation Reduction. Today we'll discuss about the that oxidation, what is the oxidation, what is the reduction, what is the oxidation number, how we can determine the oxidation number, and this all these things are included in the unit 3 of the basic chemistry. So first of all, if we want to discuss about the oxidation, then how we can define the oxidation. So oxidation means, generally we can define that oxidation means is the loss of electrons. Okay, so how we can define the oxidation? For example, if we take the example of the like sodium. Okay, so sodium, after losing one electron, what happened? It become Na plus E, isn't it? So here what happened? Here look here that it is the loss of electrons. So where loss of electrons occur, electron or more than one electrons occur, then what happened? This is the example of the oxidation. So this is called, it is the example of the oxidation. This can be applicable not only for neutral atom, it can be applicable for any of the ions also, in fact cations also. Like if we take the example like Fe2 plus. So if Fe2 plus lose one electron, then what happened? Fe3 plus will form. Okay, this can be applicable for, it can also be applicable for anion also. Like if you take the example of I minus, for example 2I minus, then what happened? If it after losing one electron, then what happened? I2 plus 2E. For balancing purpose, here 2 is included. So in this way, there may be for the neutral atom, for the cations, or for the anions, there in any case either their loss of electrons occur. Loss of electrons means when there will be loss of electrons, then obviously it is called the oxidation reaction. Now if we move to the reduction reaction, then what happened? Reduction means, look here, reduction means it's opposite that of oxidation. That means, what is the reduction? Reduction means gain of electrons. It is the gain of electrons. For example, if you take the example of the any of the example of the like H plus. Okay, so if you take the example of H plus plus E, then it is converted to the H. So this is the gain of electrons. When there will be gaining of electrons, then it is included in the category of the reduction. Like if you take the example of the cations also, like if it is Fe3 plus E, then it is converted to the Fe2 plus. It is also the example of the reduction. Then if you take the example of the any of the example you can take that where there is such kind of gaining of the electrons, then it is called the reduction. So finally, oxidation, if you think about oxidation and reduction, then what happened? Oxidation means it is the loss of electrons, and reduction means it is the gain of electrons. Now there are two terms which are very important and which you have to understand properly, because in these two terms actually students, there is a huge confusion occur in the exam time for the students. What are the terms? The terms are actually one is the oxidant, first one is the oxidant, and second one is the reductant. Okay, so first we will try to understand what is the oxidant and what is the reductant. Now first we'll try to understand what is the oxidant. Okay, so what is the oxidant? So what is the oxidant? Oxidant means, you have to keep in mind that oxidant means the substance which oxidize other, and it will be self reduced. It will be self reduced. Okay, so oxidant means which oxidized other, okay, or oxidizes other, and it will be self reduced. This type of compounds are called oxidant. There are so many examples of the good oxidants, like if you take the example of the oxygen, first of all, it is a very good oxidant. Generally it oxidize other, but it self reduced. Okay, like there is a very common example. This is the hydrogen peroxide. It is the H2O2, hydrogen peroxide. It is the another example where you can understand properly, or there are so many examples of the hydrogen peroxide where it is used as the oxidant. There is another very common example, that is the nitric acid, HNO3. This is another example of the oxidant. So these are the good oxidant because these are the self reduced. I will show you the reaction. When I will discuss about the reaction, then it will be more clear to you that how oxygen, H2O2 or HNO3, how we can understand that these are the oxidant, or these are the oxidized other and self reduced. In another way, the opposite that of oxidant, this is called, this is the actually reductant. Okay, so another name in this field, this is the reductant. Now what is the reductant? A reductant means which reduce other, and it will be self oxidized. Okay, so that means reductant and oxidant, these two names are very much related with the others. That means if it is oxidant, then obviously it oxidizes other. If it is reductant, then reduce other, and obviously there will be opposite thing will happen with this particular compound. There are so many common examples of the reductant, like the alkali metals, like sodium, like potassium, like rubidium, cesium. These all are the good examples of the reductant. Okay, so reductant means it will be self oxidized. Now self oxidized means, look here, if you understand properly that self oxidized means obviously oxidation means, if you take the example of sodium, then sodium after losing Na plus E, so that means this is the example of the oxidation. So if sodium self oxidized, if it is the self oxidized, then obviously it reduce other, so in this manner actually the term oxidant and reductant we can explain. Now one redox reaction means, what is the meaning of the redox reaction? Redox reaction means it is the combination of oxidation, and reduction. Okay, so redox reaction means it is the combination of oxidation and the reduction. Okay, so one part of the reaction, obviously there will be oxidation, another part there must be reduction. For example, I can give you one example, like if you take the examples of the, if you take the very common example, like if you take the examples of the zinc plus copper 2 plus, the very common example actually, then what is produced zinc 2 plus copper. So look here, it is a redox reaction. Why redox reaction? Because the reaction is a two half reactions also, like from zinc to Zn2 plus, it is one half, and another copper 2 plus to copper. So obviously look here, zinc to Zn2 plus, this is the, because here you can add the zinc to Zn2 plus means, if I write down here then zinc 2 Zn2 plus 2E. So that means it is the example of the oxidation, isn't it? It is the example of the oxidation. So here we can write down, this is the example of the oxidation. So this half reaction is called the oxidation reaction. Another way, you know, if you try to understand copper 2 plus, so copper 2 plus 2E to copper. Okay, so that means this is the gaining of the electrons. So gaining of the electrons means it is the reduction. So here you can write down reduction. So that means look here, one complete reaction. This is the redox reaction actually. Why? Because it is the combination of oxidation and reduction. So one part is oxidation, another part is the reduction. So in this way actually we can understand what is the redox reaction. Now come to the most important part of the chapter, okay, and this is called the oxidation number, because if we do not understand properly what is the oxidation number, then all the things become meaningless. Okay, because first of all we have to understand the oxidation number, then we can understand what is the all other things, or how we can determine the and how we can understand which will be oxidized, which will be reduced in a reaction, how we can, it is possible to make a balance of the reaction by oxidation number method, etc, etc. All these things will be possible if we understand properly oxidation number. So what is the oxidation number? Oxidation number. So first of all, literally we can define that oxidation number of an element in a compound is a definite number which indicates the extent of oxidation or reduction to convert an atom of the element from its free state to its bonded state in the compound. Okay, this is the definition of the oxidation number. Now I will show you. For example, if you write down H2, then here the oxidation number of the oxygen is -2. So this is called the oxidation number. This is called the oxidation number. For any of the compound you can take the as an example. Okay, but first of all you have to understand, you have to know there are some rules by which we can determine the oxidation number of an element. So what are the rules? What are the rules, okay, by which we can determine the oxidation number of any of the elements? So first one, okay, so first one, the oxidation number of an element in its free or elementary state is taken as 0. For example, like if you take the zinc, if you take the copper, if you take the Cl2, if you take the P4 phosphorus, if you take the S8, so this type of compounds, okay, so all these cases if you take the examples, their oxidation number will be 0. Okay, so in each and every case oxidation number will be 0. So this is the very important thing which you have to keep in mind, and this is the first rule of calculating the oxidation number, that the oxidation number of any element in its free state, it must be 0. Now come to the second rule. What is the second rule? The second rule is that, according to the second rule, that the oxidation number of a monoatomic ion in an ionic compound is equal to its charge. For example, like if you take the example of the FeCl2, okay, FeCl2. So in FeCl2, that FeCl2 exists as the Fe2 plus and Cl minus. So in FeCl2, the oxidation number of Fe and Cl are +2 and -1 respectively. This is the +2 for Fe, and Cl minus is the -1. So here Fe we can write down, it is the +2 and it is the -1. So one thing you have to keep in mind here, that for a neutral compound, for any of the neutral compound, the sum of the oxidation numbers of all the elements will be 0. This is a very important thing which you have to keep in mind. Okay, so here also you can think here, or you can check here that FeCl2 here, it is the +2 and it is the -1 for each and every Cl. So if it is each and every Cl -1, so we can write down -1 into 2, so overall it will be 0. So in this way we can conclude that the sum of any of the neutral compound, sum of the oxidation numbers of all the elements will be 0. And if it is the any case of it is ion, any of the ionic compound, then what happen, the sum of the atomic number, okay, if it is any ionic compound, okay, if it is any ionic compound, any of the ionic compound, then the sum will be equal to the charge of the compound. If it is neutral, it will be equal to 0. If it is any ionic compound, then it will be equal to the charge. Now come to the next rule, that determination of oxidation numbers of the atoms, like like in case of if you think about the any of the metal, okay, metallic hydride, for example, if you take the example of the like NaH, like metallic hydride, if you take any of the such kind of example like NaH, then what happen, that in metallic hydride it is always for the hydride it will be -1, and for sodium it will be +1. So any of the hydride compound, hydrogen, that will have the -1 charge always, okay, for hydride compound. Like if you take the example of the any other here calcium hydride, if you take the example of the calcium hydride, then its formula will be CaH2, its formula will be CaH2. So if it is CaH2, then if it is -1, obviously it will be +2, otherwise 0 will not be possible. So each and every hydrogen it will be -1, and then it will be the +2. In all the hydrogen containing compound except metallic hydride, other than metallic hydride, all the hydrogen compound hydrogen containing compound, the oxidation number of hydrogen will be +1. Keep in mind. Okay, so only for hydride case it will be -1. Other than hydride case, all other hydrogen containing compound, the oxidation number of hydrogen will be +1. I can give you so many examples also, like if you take the example of NH3, here it will be +1, and obviously it will be +3, because each and every hydrogen +1. So for 3 hydrogen it will be +3. If you take the example of H2O, it will be +1 and it will be -2, because each and every hydrogen will be +1. So 2 hydrogens are present. If it is the NaHCO3, then it will be the +1. So in this way we can determine, or we can use the oxidation number for hydrogen also. Oxidation number, general oxidation number of oxygen in its compound, okay, oxidation number of oxygen in its compound, it will be generally, it will be, you have to keep in mind, -2. For oxygen it will be -2. This is very important, you have to keep in mind, okay. And any of the oxygen compound containing compound, but in all the fluorine containing compound, the oxidation number of fluorine will be -1. Okay, any of the fluorine containing compound, it will be -1. But you have to keep in mind one thing, there will be some cases of oxygen. Okay, oxygen will be -2, but if it is the peroxide compound like H2O, you have to keep in mind, if it is the peroxide compound, then it will be -1. Okay, H2O2, sorry, it is the peroxide compound H2O2, then it will be -1. So you have to keep in mind that if it is peroxide, then it will be -1. If it is the superoxide, okay, it is the peroxide, if it is the superoxide, superoxide means if it is a superoxide, for example, like KO2, for example KO2. So if it is superoxide, then what happened? If it is superoxide, then obviously here the oxidation number of the oxygen will be -12. So for superoxide, their oxidation number will be -12 for the oxygen. Okay, for the oxygen. Now if the fluorine is the most electronegative atom, you know that when oxygen attach with fluorine, like the compound of F2O, then their positive oxidation number also possible, because in this case it is the +2. So you have to keep in mind that when oxygen attach with the fluorine also, then its oxidation number become positive, like in case of F2O it become the +2. Okay, now you know there are some elements which always show the fixed oxidation number in the compounds, like alkali metals. So if you think about the alkali metals, then alkali metals means like lithium, like sodium, like potassium, they always show the +1 oxidation state. Okay, this is the constant, they always show the +1 oxidation state. On the other hand, there are some compounds also, alkaline earth metals, like beryllium, like magnesium, okay, like magnesium, like calcium, they always show the oxidation state +2. Okay, so look here that beryllium, magnesium, calcium, these are the alkaline earth metals, so that's why they have the fixed oxidation number. So you have to keep in mind this fact. Okay, so this is very important also, that oxidation number of alkali metals, it is the +1, and oxidation number for alkaline earth metals, it is the +2. Okay, the maximum oxidation number of an element cannot exceed its group number in the periodic table. So these all the things you have to keep in mind, and depending on these all the rules, you have to calculate the oxidation number of the elements. I'll show you few examples, then you have to practice a lot by which you can determine the oxidation number. So first of all, I will give you some examples of the how we can calculate the oxidation number. For example, we have to calculate the oxidation number of sulfur in the H2SO4. Okay, so you have to calculate what is the oxidation number of the sulfur here, oxidation number of the sulfur. So now for this case, you know it is a neutral compound, so sum of all the oxidation number of all the elements will be 0. Okay, you have to keep in mind this fact. So now first of all, hydrogen, you know, so if I write down here H2SO4, so first of all, look here that for hydrogen it is the +1, oxygen -2, so total here +2, total here -8. So if we take that it is the X, okay, the oxidation number of the sulfur is X actually, so then we can write down +2 plus X -8, that equals to 0, and X equals to +6. So that means the oxidation number of the sulfur, this is the +6. So this is in this way we can determine the oxidation number. I can give you another examples also, that if we want to determine that what is the oxidation number of KClO4. Okay, so what will be the oxidation number for the KClO4? So then here, if we take the examples of the KClO4, then first of all, you know, for KCl, for potassium, it is the alkaline metal, so it will be the +1. We have to determine what is the oxidation number for the Cl, and it is the -2. So that means +1, for example Cl, it is the x -8, that equals to 0. So x equal to +7. So in this way we can determine the oxidation number of any of the compound. Then another case, if we take the examples of the NH4NO3, if we take the examples of the NH4NO3, then look here, there are two ways by which we can calculate. First of all, if I want to calculate their NH4 plus part, okay, so if I dissociate it, then it will be NH4 plus and NO3 minus. Okay, so then what I told that it is not the neutral compound, so obviously here the sum will be +1. For example, if we take the nitrogen X and hydrogen, obviously +1, so +4 equal to +1. So x equal to -3. So that means here nitrogen will be -3, and in the same way you can determine what will be the oxidation number of this nitrogen also. So in this way we can calculate the oxidation number of the NH4NO3. So now another way, that there are some exceptions also during the calculation of oxidation number. Then the exception is, first of all, there are very common example. If you take the example of the such kind of compound like CrO5, okay, so in CrO5 the general question is that what is the oxidation number of chromium here. So generally what student do here, that this is a very simple case. So here it is expected that oxygen has the -2, so -2 into 5, then it is the 10 -10. So obviously it is expected that chromium has the +10, but it is actually not right. It is actually not right. Chromium has the chromium in this compound, chromium oxidation number of the chromium is not +10. So what we have to do, we have to know the structure of the compound. Like, what is the structure of the compound? Here chromium, it is the structure is like this. So it is the structure of, looks like a butterfly, structure of the chromium. And look, it is the peroxide bond also there. So if it is the peroxide bond, then obviously what happened here, it will be the -1. So this oxygen -1, this oxygen -1, -1, and it is the -2. So what happened? So here, look here, 4 into -1 plus -2, for example chromium X equal to 0, so X equal to +6. so the oxidation number of the chromium is +6, it's not +10. so you have to keep in mind in this way that here the oxidation number of the chromium is +6, not it is the 10. So there are some kinds of exception case also there, which you have to keep in mind and which you have to practice a lot, where the concept of structure you have to keep in mind. For example, I can give you some examples of such kind of exceptional case also, which you can take that this is your home task. If you think about the H2SO5, H2SO5. So here you have to find out what is the oxidation number of the sulfur. Okay, you have to find out what is the oxidation number of the sulfur. Then another example is the Na2H2O3. Na2H2O3. Then what is the oxidation number of the two sulfurs? Okay, this also you have to understand properly the structure of the Na2H2O3, otherwise it is not possible. Okay, another thing is that you have to also understand that there are some kind of examples, very common examples, that of what is the oxidation number of like iron in K4 FeCnL whole 6. Okay, this may be the example, K4 FeCnL whole 6, FeCn whole 6. So here what is the oxidation number of the Fe? So here the simple, very simple case, that just at first dissociate the compound, that 4K plus and the remaining part it will be FeCn whole 6 4 minus. Now you can, I think you are able to solve, because Cn is the -1. So you are able to solve what is the oxidation number of the iron in this case. So in this boy you have to practice a lot, because in the next class we will discuss about that how, with the help of this oxidation number, how you can predict that in a compound which is oxidizing and which is reducing, because this is very important, that you have to understand properly the reaction, which is the oxidizing part and which is the reducing part. So that's all for today. Thanks for watching. Meet with you in the next class with the different topic. Thank you.